Hello, Frank Conjal with Zeiss with another video walkthrough for Zeiss CALYPSO Programming Level 1 Final Exercise. The final exercise begins on page 126. In this exercise, you'll put together everything that you've learned this week in training into one conclusive program. First, we'll begin by fixturing the part as shown on the CMM. Again, this is just for visual purposes, as we'll be using a CAD model and we won't be probing the part. This print consists of 20 dimensions. Let's begin on the lower right. First, we'll create a CALYPSO measurement plan and load the CAD model. No need to transform the CAD model because the trihedron is in the same orientation as how it sits on the CMM. Before we go any further, we should turn on filters and outliers. This program will be using the star probe, so when creating features, we need to be sure that we're using the correct active tip. I'll activate my down probe, choose the top plane. I'll activate my back probe, use the front plane, and I'll activate my left tip and use the right plane. This is a suitable base alignment. We can then do clearance planes. And we can choose CALYPSO's suggestions if we choose. Looking at our manual on the lower right, we'll begin with the 12 diameter plus or minus 0.1 and the true position of the lower right circle. We'll activate our down tip. Before creating a feature, we'll go ahead and drop in a position. Go into circle on cylinder CAD mode, create a circle. The datums for this true position are datums A, B, and C with an MMC modifier. Datum A is the top plane, datum B is the front plane, datum C is the right plane. Here we can choose datum A, datum B, and datum C. Tolerance is 0.1. Using the modifier, we'll choose MMC. This question here is asking if we should create a new diameter characteristic for the MMC. Finally, when there's a discrepancy between the CAD and the print, you must choose one of the two. In this case, we're going to go with the print nominals. The basic dimensions are 20.55 and 12.55. We'll clean these up. And this position and diameter are complete. The next characteristic is a Cartesian distance between the two keyway slot planes of 12 millimeters plus or minus 0.1. Still using our down probe, we can do a size, distance, Cartesian distance. And we can choose the left plane and the right plane. No datums needed for plane features. Nominal intolerance is correct. Next is our 63.566 Cartesian distance. This will be a distance from the front plane to an intersection point on the back left corner. We'll do this by first creating an intersection point between these three planes. Note that these features haven't been created yet, so we need to follow our active probe, we can choose this plane, activate our right tip, choose this plane, and perhaps activate our front tip and choose the back angled plane. We now have an intersection. We can then do size, distance, Cartesian. This is a distance from the front plane to the intersection. Clean up the nominal. Tolerance is 0.05, negative 0.05. Next is a 25 millimeter distance. This will yet again be another Cartesian distance between two intersection points. The intersection point that we already have created and a new intersection point on the back edge. To create this intersection, we'll drop in an intersection. This intersection will be of the same two planes and using the backside plane as the third. We don't have this created yet, so we'll activate our front tip and choose the plane. Intersection 2 will be used in a size, distance, Cartesian distance. This distance will be between intersection 1, intersection 2. Since these are point reducible features, we need datums. We can use the top plane as the primary datum, and perhaps we could say parallel to the backside plane for our secondary datum. Nominal and tolerance are correct. Backside 51 millimeter distance would be a Cartesian distance from the intersection just created and the right side plane. Dropping in a size, distance, Cartesian. We can then choose the right side plane using maybe our front probe. And we can extract this plane using define select geometry. Feature 2 would be intersection number 2. No datums needed. Correct nominal, correct tolerance. Next is the roundness of the large counterbore on top. We can go ahead and drop in a roundness, open this up, and using our down probe, we can extract a circle on top. Tolerance is 0.1. Finally, the 12 millimeter diameter characteristic on top. Again, using our down probe, in circle mode, we can choose a circle. We can open this circle up, check the diameter button. Tolerance should be plus or minus 0.05. That satisfies all characteristics in the lower right portion of the print. Remember, we do not report basic dimensions. Moving up, 10 millimeter distance here will be a Cartesian distance from the top to the middle inside keyway slot plane. We can drop in a size, distance, Cartesian, and we can go from the smaller plane first to the plane on top. Nominal and tolerance are correct. The next dimension on our print will be the 46 distance here. This will be a polar caliper distance between the top circle and the bottom circle. We can drop in a size, distance, polar caliper distance. Activating our back tip, we can create two circles. And our primary datum can be the front plane. Nominal is 46, plus or minus 0.15. The defaults for maximum are exactly what we're looking for. The next distance is the 15 millimeter distance here from the center of the through bore or the counter bore, however you'd like to interpret the print, to the center of the lower right circle. This would be another Cartesian distance. We can go to size, distance, Cartesian. We can then choose the circle we've created. We can check to see if we've created a circle here. We have not. So using our back probe, we can create a circle on the front. Primary and secondary datums are needed here. So we can use the front plane as our primary, parallel to, and we can use our side plane as our secondary datum. Nominal is correct, 15 plus or minus 0.1. Next would be 30 millimeter diameter of the large counter bore. This is circle 6, so we can just go into the feature, check the diameter. 30 plus or minus 0.1. Finally, on this view, we have a flatness of the top plane to 0.1 tolerance. We can drop in a flatness, choose the top plane, and the tolerance is 0.1. Moving on in our print, this distance 60 millimeters from the left to the right side. This would be a Cartesian distance from plane to plane. We can drop in a size, distance, Cartesian, and we can choose our front plane and a plane that has not yet been created. We can activate our left tip and create the plane. No datums needed. Nominal is 60 plus or minus 0.15. The next characteristic is a diameter of 42. This crosses through all the center holes. In this case, we'll create a brand new circle and use the recall function in CALYPSO to achieve this diameter. First, we can test to see if any circles have been created yet. We can now be sure that the left probe is activated. For simplicity, I will only measure the 4 outermost large circles. That is circles 7, 8, 9, and 10. I can then drop in a brand new circle. Using the options drop-down, we'll choose recall. And we'll choose circles 7, 8, 9, and 10. This will create the circle, and then we can report the diameter. 42 plus or minus 0.1. Moving on, the next distance is 63 from the top to the bottom. This will be a Cartesian distance. We can drop in a size, distance, Cartesian. We can choose the top plane. We have not created a bottom side plane. In this case, it doesn't matter what our stylus chosen is before we extract this plane, because we will need to modify the strategy of this bottom side plane. 63 plus or minus 0.2. No datums are needed, as one of the planes, or both, are in feature 1 or 2. The next characteristic is an angularity of the angled plane to datum A, which is the top plane. We can drop in a form and location angularity. The feature being controlled is the angled plane. The datum is datum A. The tolerance is 0.1. The basic angle on the print is 40. That is correct. The next dimensions are the 15 millimeter diameter, as well as a concentricity from this bore to datum D. Datum D from the print is the primary counter bore. We can activate our front tip to create a circle here by going down and choosing Define Circle on a Cylinder. We can then report the diameter first, 15 plus or minus 0.1. Then we can drop in a concentricity. We can then choose the circle 12 as the feature being controlled, and the datum D. Tolerance is 0.4. The final characteristic on this print is 92 dimension. This is a Cartesian distance from the right to the left side plane. We can drop in a size, distance, Cartesian distance. We can then choose the left side plane and the right side plane. 92 plus or minus 0.15, that is correct. There may be a few strategies that we need to modify before running. For example, the bottom plane. The easiest way to do this is to delete the polyline. Activating my back tip, we can then create points on the bottom. Activating my left tip, we can create 2 more points. Activating my front tip, we can create 2 more points. And then finally activating the right tip, creating points. Each pair of points can be made into a polyline. Watch your speed and step width. And finally, we need a clearance data in between each polyline. Be sure that each clearance data corresponds to its appropriate polyline. This clearance data corresponds to the first polyline on the front, so that needs to come from the negative y. The second clearance data corresponds to the second polyline, so this needs to come from the plus x. The third clearance data applies to the polyline on the back, so this needs to come from the CP plus y. And finally, this clearance data corresponds to the polyline on the left, so that means this needs to come from the CP minus x. Be sure to hit no if you don't want CALYPSO to make changes to your strategy. Finally, before we run, we can go to the Measurement tab, Multiple Report. We can turn on Plots, and then here using Display Plots in Report, we can choose which plots will show up on the report. All form-related characteristics can be shown, as well as other GD&T characteristics. If there are any other features to modify on this part, do so now before running. Once you're ready, you can run using a manual alignment. Be sure to follow the prompts in the manual alignment. If you see during the alignment that the probe is incorrect shown here, cancel the run and go fix the stylus for that feature. Once your program runs through, please send the entire program by zipping up the program in a compressed zipped folder and emailing that to your instructor for review.